We're going to start today by reviewing finite differences, and we call those rates of change in grade 9. So let's talk about what we learned already, linear relations. We're going back to that. How can you tell if a relationship is linear? So if you look at the graph, you should see a straight line. If you look at the equation, you should have no exponents. The degree is 1, that means the highest exponent is a 1. If you look at the first differences, which means you are looking at a table of values, then when you subtract your y2 minus y1 values, they have to be the same, they have to be constant. And then they tell us about the slope of the line, these first differences. Note something that's important is let me just change my highlight color for this here. The x values must increase at even intervals. If they increase by 1, then we can actually find out the slope of the data. So looking at our first chart here, first of all, it's important that we look at the x values. They are increasing, where negative 10 is a negative number, and then we end up at a positive number. So these are going from negative to positive, so they're increasing. Are they evenly spaced? Are they increasing by the same amount? So to get from negative 10 to a negative 5, that's an increase of 5. Negative 5 to 0 is also an increase of 5, and 0 to 5 is also an increase of 5. So yes, they're evenly spaced. Now what's not happening though is they're not increasing by 1. That's not happening. They're increasing by 5, but that's okay. It just means that we can't find the actual slope like this with the strategies we have right here, but that's fine. We are still going to learn something about the slope, we just won't know what the slope is exactly. So let's find the first differences, y2 minus y1. This is my second y value, and I want to subtract from it the one above it. 44 minus 36. So you'll notice a little grayed out section there. That's just because I don't want to line them up perfectly. I'm kind of going in between two numbers, so I want to write in between the two numbers. 44 minus 36 is 8. How about the next pair? 52 minus 44. What's 52 subtract 44? Well, it's also 8. And how about 60 subtract 52? It's also 8. So this is asking if it's constant. Yes, constant means the same number. 8 is the constant. So what does it tell us about the slope? Well, we don't know what the slope is, but since our first differences are positive, it tells us that the slope is positive. So this is a line. This is linear because our first differences are constant. So I know it's going to be a line, and I know it's going to have a positive slope. That's what I found out from my first differences. Let's do another table. First differences, again. So I'm going to take 5 and I'm going to subtract the one above it. 5 subtract 7. That's a negative 2. Now I forgot to start with my x values here. Looking at the x values, they're all evenly spaced, and these ones are all increasing by 1. So these numbers are all, we're adding 1, adding 1, adding 1 each time. So each time we're adding 1, that means we're actually going to be able to find out the slope here when we're done. So let's keep going with our first differences. Now I take 3 and I subtract the number above it. That's a 5. That's again a negative 2. 1 subtract 3 is again negative 2. And then negative 1 subtract 1 is negative 2. So we know that the slope in this case is not just negative because we got a negative for our first differences, but the slope is actually a negative 2 here. And we can only know that for sure when we have our x values increasing by 1 each time. That's the only way we can find out for sure what the slope is from a table of values. So let's review of linear. Now let's talk about quadratic. We can determine whether or not a relation is quadratic with the same 3 methods. So we can look at the graph, and we already know this. It's going to have a kind of a U shape, and we call that a parabola. We can look at the graph to determine if it's quadratic. We can look at the equation, and here we're looking for x squared, or there would be 2 x's if it was in factored form. And we can also use a table of values like we're going to here. We can use a table of values, but this time we're looking at the second differences, not the first differences, the second differences, and they have to be constant. So in order to get the second differences, we need the first differences. But first, let's look at our x values. Are they all increasing evenly to get from one to the next? Yes, they're all increasing by 1. So that's important. If they weren't, I would have to reorganize them so they were going in order. So these ones are going in order. Sometimes your textbook will throw a few incorrect ones there. They might add in a number here, like say they had -2 in there, and then they had a whatever 4. You would have to rewrite that. You'd have to pick that up, and you'd have to write it up here at the top because they have to be written in order from lowest x value to highest x value. Okay. So now let's look at our first differences. I take the second one, I subtract the one above it. -4, subtract, careful with the negatives, -3. That's really -4 plus 3, right? 2 negatives make a positive. -4 plus 3 is -1. Now I take the second one, -3, subtract the one above it, -4. -3, subtract -4, that's -3 plus 4, that's a +1. So already my first differences aren't the same. Now you might be thinking, well, maybe I made a mistake with my negatives are kind of crazy. Sometimes we mess those up. Let's keep going. Maybe they are the same. So I'm taking 0 and I'm subtracting -3 from that. That's really 0 plus 3. That's 3. Okay, so this is not looking good. 5 subtract 0 is 5. Okay. Definitely not linear. Not linear because I didn't get constant first differences, so it's not linear. So I can't look at this and say, oh, look at my slope has got to be a 5 or something. No, it's not a line, so it's not going to have a constant slope. So we move on and we look at the second differences. Second differences. So second differences, I take this second one and I subtract the one above it. So I'm doing 1 subtract -1 here. And that's really 1 plus 1. So that's a 2. Do it again. I'm taking the first differences. I'm taking the second one, which is a 3. I subtract the one above it. That was a 1. 3 subtract 1 is 2. And one more time, I've got a 5. And I subtract a 3. I get a 2 again. My second differences are constant. That means this is quadratic. This data, the data meaning the numbers in the chart, this data is quadratic. So the fact that I got a +2 does not mean, oh, my slope is 2, because look at these parabolas down here. They're not lines. They don't have slopes. We only talk about slopes when we have linear relations up here. Up here we would talk about the slopes. You will never hear me talk about the slope of a parabola. Well, not until you get to advanced functions, maybe we would talk about that, but no slopes of parabolas. So this number 2 right now, we don't need, it doesn't tell us anything that we need to know right now. It does, but we're not worried about that. So all you have to see is are these numbers the same? If they're constant, yes, then it's quadratic. This is not having, this won't have anything to do with the slope because it's not linear, right? It's not linear, so we can't be talking about the slope here. Moving along. Label the parabolas with our new terminology. Vertex, axis of symmetry, max min point, intercept, y-intercept, direction of opening, all this stuff. So let's start with the first one, vertex. The vertex is the turning point, really. It's the most curved point. This vertex has the coordinate 1, -4. This vertex up here has the coordinate -2, 1. Remember, we label the x first and then the y. That's the vertex. Next, we'll do the axis of symmetry. The axis of symmetry, remember, goes right through, it goes straight through my vertex. So you get out your ruler and you line up your ruler with your vertex and you draw a dotted line right through it there. I'm gonna have to erase those little messy marks I made there. That's my axis of symmetry. Erase this stuff. That's my axis of symmetry for the first graph, and it has an equation. Remember, axis has an x in it, so the equation is x equals, and again, look at the x value. This is an x, this is a y. X equals 1. That's the equation of my axis of symmetry. Let's go to the other one and put a line through this one. See if I can make this one a little neater. Vertical line straight through here. The axis of symmetry divides my parabola in half. This one has the equation x equals, it's one of these two numbers. Which of those two numbers is it? It's the x. X equals -2. That's the axis of symmetry. So that takes care of the axis of symmetry. Now we want to talk about the maximum minimum. So first of all, you have to decide, is it a maximum or is it a minimum? On the first graph here, the vertex, is the vertex the maximum or the minimum? It's the minimum. And the minimum, the lowest minimum, we're always talking about the y value there. So the minimum value that this parabola is ever going to hit is a -4. It's not going to get any lower than that. So we have a minimum at y equals -4. That's a y. How about the other parabola? Now this parabola, the vertex is not the minimum. This time the vertex is a maximum. It's the highest point. So we have a maximum at y equals, what's the highest value, y value we're going to have? It's this number here, 1. We have a maximum at 1. So we've taken care of the maximum minimum. Next thing we want to look at are the x-intercepts. Okay, the x-intercepts. The x-intercepts are where your parabola crosses the x-axis. So it crosses here and here. So my x-intercepts, I'm going to write them as a coordinate. The coordinate right there, I have x-intercepts. Write that down. X-intercept, you sometimes will also, instead of that, see the word zeros, the x-intercepts or the zeros. The first one is at -3, 0. That's the coordinate of this one right here. The coordinate of the other one is 3, 0. Is that right? Oh, sorry, the first one's not -3, it's -1. Oops. Whoops. Let me erase that. -1. I don't know where I got the 3 from. I was looking ahead, I think, to the next one. -1, 0, and the other one is 3, 0. How about the x-intercepts here? We've got an x-intercept right there. What's the coordinate of that dot I just made? What's the coordinate there? There's my -3. So that's a -3, 0. And my other x-intercept is right here. And that's -1, 0. So those are the x values of the x-intercept. X-intercepts are done. How about y-intercept? Y-intercept is where the graph crosses the y-axis. I've kind of written all over this, so I'm going to erase this green line here. And I'll erase this one. So the y-intercept, here's my y-axis right here. Where does my parabola cross the y-axis? It crosses right here. That's my y-intercept. So my y-intercept, again, is a coordinate. My y-intercept, this time we have an x value of 0 and a y value of -3. -3 is everywhere today. And the other graph, -3. There's my y-intercept. There's another -3. So the y-intercept here is also 0, -3. They have the same y-intercept. Y-intercept is done. Last one is direction of opening. Direction of opening, that means you look for the open part. The open part of this graph is up here. This is the open part up here, between here and here. So the opening is at the top, which means the parabola opens up. The opening is facing up. So this one opens up. And the other parabola opens down. Any of these pieces that you've forgotten, you need to go back and look at the video from 6.3 about the key features of parabolas, because we have already talked about all these. So that's the direction of the opening. Okay, next example. This one's our last one. Try to fit it all in the box there. Ooh, that was my phone. Okay. Next example, make a table of values for the relation y equals x squared plus 3x minus 18, and then calculate the first and second differences, then graph the relationship. So we did tables of values in our previous lesson. Again, if this feels like it's brand new for you, you're going to need to go back and watch another video. My first x value is a -4. So everywhere here that I have an x, I'm going to have to put a -4 in its place. So I get y equals, always substitute with brackets, especially when we have negatives, -4 squared plus 3 times -4 minus 18. So order of operations, I'm going to do the brackets here, the exponents. -4 squared is a positive 16. 3 times -4 is minus 12, and then plus 18. I shouldn't be writing so close to the side here because now I'm kind of running out of room. My answer, 16 minus 12 plus 18 is -14. So that's a -14. Next one, I'll move it over a bit so I don't crowd myself out. Subbing in a -3. So again, we sub it into both parts. I get y equals -3 squared plus 3 times -3 minus 18. That is 9 minus 9 minus 18. So we sub in a -3. 9 minus 9 is 0. I get this is equal to -18. 2. So I'll do one more with you and then get you to do the rest on your own. -2 squared plus 3 times -2 minus 18. That is 4 minus 6 minus 18. That's going to give us a -20. So I'm going to press pause and I'm going to fill in the rest, and I suggest you press pause too, and then we'll check our answers with each other. Okay, how'd you do? Did you get these numbers? So check them and see that they're right. And now we're going to calculate first differences. So first differences, I take my y2, well, let's go with red. y2, that's -18, and I'm going to subtract the one above it, subtract -14. That was a bit messy, so I just rewrote it there. -18, that's -18 plus 14. So I'm going to get my first difference is a -4. Now let's do our next pair. That's -20 subtract -18, which is -20 plus 18. That's going to give me a -2. So it's not looking linear because my first differences are not the same. Next pair, -20 subtract -20. That is -20 plus 20. We get a 0. Next pair is -18 subtract -20. That's -18 plus 20, which is a 2. And then my last pair here is -14 subtract -18. Again, negatives making positives. -14 plus 18 is 4. So there are my first differences, and they are not constant, they are not the same. Therefore, it's not linear. Now we knew that already, because when we look at this equation, remember at the beginning I talked about how you can tell if something is linear from its equation? I can tell from that equation it's not linear because it's got a power of 2 in there. It's got an exponent of 2, or what we call a degree of 2. Because of that power of 2, I know it's not linear. I already know that. But I can't calculate the second differences without calculating the first differences. I need these numbers. And the question said I had to calculate first and second differences. So I have to do this anyway, even though I already know it's not going to be linear. So let's get on to our second differences. I take the -2, I subtract the 1 above it. -2 subtract -4. That's -2 plus 4. That's a 2. Next pair is 0 subtract -2, which is really 0 plus 2, which of course is 2. Perfect. Beautiful. This is what I'm expecting. I'm expecting them to be the same because I already know by looking at this equation. I already know that it's quadratic when I look at it. Because of that, I know that, let me scroll up here. I know that if I have an equation, I can look at the equation and I can know it's quadratic if I've got this x squared. So I already know it's quadratic, but the question's telling me to find first and second differences, so I have to. If it just said, if the question just said, look at this equation, is it linear or quadratic? Well, it's quadratic. I wouldn't have to do all this stuff, but I do. So back to work. Second difference is 2 subtract 0. I don't need to do any extra work there. That's just a 2. And then 4 subtract 2. 4 subtract 2 is 2. So the second differences are constant, which I knew was going to happen. So my second differences are a 2. So I know that that tells me it is quadratic, which I already knew. Quadratic because the second differences are constant. Doesn't matter if they're 2. They could be 500. They could all be 500, 500, 500. Doesn't matter. But if they're all the same, then it's quadratic. So our next step for this question is to graph the relation. This time I'm giving you a grid that doesn't already have an x and y axes drawn on it. So I'm going to draw my own on here. So I'm going to take a second to think about the x values and the y values I need. The x values are all, well, they're not all negative, but they're mostly negative here. I've got a positive one too. My y values, so the y values are a little harder to see because I wrote over them a bit. So here's my y values. That's a -14. So my coordinate, my first coordinate, I'll write it here. My first coordinate is -4, -14. My second coordinate is -3, and then I got a -18. Then I have a -2 with a -20. I have -1 and -20 again. 0, this will be my y-intercept, right? 0, because I've got an x value of 0, 0, -18, that's my y-intercept right there. And then 1 and -14. So those are all some pretty big negative numbers, which means when I draw my x-axis, I'm going to draw my x-axis up a little higher here. So I'm going to put it, well, see how well, it's hard for me to draw on this tablet, but we'll see how it goes here. I'm going to put an x-axis about here because I need a lot of space below it for all those negative numbers. The y-axis, I'm just going to draw that one down through the middle, if I can. That wasn't very good. I'm going to have to fix that. Okay, this is my y-axis, this is my x-axis. Now I need a scale. Let's look at our x values first. Our x values are pretty small. I don't need a lot of big numbers there. So I could probably skip count 1, 2, 3, 4. It might be close. I'll just count by ones here. So that's going to be a -1, but I'm going to just label this next one -2, -3. Whoops, that moved over, -4. I don't really need any more, but I'm going to put them on anyway. And then I've got 1, 2, 3, 4. Don't forget to label a lot out of your axes. You can't just label the numbers you want to use. You have to put them all on there. It's improper form. If you just label certain numbers, you will lose marks for that. Now my y values, I've got to get a -20 on here. So for this case, if I count my, I don't have 20 spaces there, but I likely have 10, so I could count by 2s. So I'm counting by 2s this time, but I'm still going to label every second one, which means 4. Whoops, -4, sorry. -4, -6, nope. No, it's not, I'm going to fix this here. That wasn't a very legible -4. There's a -4. then -6 and -8, -10, -12, -14, -16, -18, -20. And I can't ignore the top of my y-axis, even though I'm really not going to use it. I have to include it. So I'm just going to fit one on there. Now let's put the points on. My first point is -4, -14. So that's always starting at the origin, to the left 4 and down 14. Right there. My next coordinate is -3, so I'm going to the left 3 and then I'm going down 18. -2 and -20. -1 and -20. And 1 and -14. Oops. Sorry, if I skipped one. I skipped the y, 0, -18. That's my y-intercept. I already talked about that, and then I skipped it. 1 and -14. There we go. That's a lovely U shape. I don't have the vertex exactly because between these two here, there should be a point a little lower, but it wasn't one that I did in my table of values, so I don't know what it is. I didn't actually sub in, so it's going to be in between -2 and -1, right? It might be -1.5. So when I draw this, I'm going to bump it down a little bit. I'm going to curve it down here to make sure I do not put a straight line because all parabolas have a vertex. So let's see how I can draw this on my tablet here. Nope, that curved in. I'm going to erase that and do a better job. Trying to hit the points, but curving down a bit. Oh, my pen did not want to connect there. So this is my parabola, and we always put an arrow on the end because the parabola continues on. These were the numbers we subbed in for x values. We certainly could have subbed more in. I could have kept going and subbed in a 2 and done a whole other row, and then I could have done a 3. I could have subbed lots of numbers in, but I only did a few to get the shape of the parabola, of the quadratic. So my equation is y equals x squared plus 3x minus 18. And that is my graph from a table of values and an equation. And I also went over, of course, first differences and second differences. Lots of stuff in today's lesson. Nothing is really brand new. We've really touched on a lot of this already. We haven't done second differences before, but we have done first differences. So you can always go back and review other videos if there are things here that you really don't remember doing or you don't understand.